Hello, I'm Tristan with the Cloud Provider Observability Squad on Grafana Labs, and today I'm going to do a little demo and kind of overview of our new AWS metric streaming integration to ship metrics from Amazon CloudWatch into Grafana Cloud. Now we'll talk a little bit about why you might want to use metric streams instead of, say, like the scrape job integration that we have, or some other means of getting your metrics into Grafana Cloud. And there's a number of reasons. I mean, like one of the biggest ones is actually cost. We ourselves at Grafana dog food this product, and we have I think around 1 million active series right now working on it, and we found that there's actually a 10 times cost savings like that we ourselves have realized from using metric streams rather than our previous scrape job infrastructure setup. So yeah, I mean, cost is like one thing, definitely at scale when you're talking about how Firehose like pricing works out with like batch data send, and also the fact that metric data points only get sent to Grafana Cloud when they actually exist in CloudWatch, whereas when you're doing some kind of like scraper exporter, that's going to run every time interval. It's going to run like every 5 minutes or something, and it's going to get a data point no matter what. So, if the data points haven't been updated and nothing's been shipped to CloudWatch because nothing's been updated, then the scrape job is just going to, waste API calls basically. Whereas AWS, like just, there's no data sent over Firehose, so there's nothing to send. So there's definitely some gains in efficiency there. On a similar vein, there's also the performance factor. Like, you definitely get closer to real-time performance with metric streaming, just because like scraping, you're always waiting for the scrape interval to happen. Whereas with streaming, Amazon will, push it as soon as it's available. It does batch things, so it's not literally instant, but I think once the um, cadence of sending has like reached some kind of like regular threshold, then it starts sending data like every minute, like, every minute, like a new batch of data will be sent. I think we found in practice that generally data is only a couple minutes behind at most. So that should be okay. And then you also get a better availability story. Like with scraping, if the time window goes by and a scrape gets missed for whatever reason, like, it's just gone. Like unless you go configure the scrape to like go back in time and get historical data. But for streaming, it's like it backs up to S3. The data is there as long as you need it. You can always try to resend it. Um, so yeah, it's just like an overall better story for that. So here we're kind of looking at the service architecture a bit, and it's mainly driven by two clients. One will be, we'll use Terraform for our example here. And one is for setting up resources in AWS in your AWS account, and the other will be setting up resources in your Grafana Cloud account. So on the AWS side, the main things are, we have some resources to monitor. These can be like EC2 instances, RDS databases, all kinds of different things. But the main point is that they are resources in AWS that push raw service metrics into Amazon CloudWatch. Now, the heart of this integration with Grafana Cloud is that CloudWatch has a feature called CloudWatch Metric Streams, which basically let you filter the raw service metrics based on things like the service namespace or metric names, or I think even statistics. And you can choose to filter certain classes of metrics and push them into an Amazon Data Firehose instance. And then we configure Amazon, or you would configure Amazon Data Firehose to then push those metrics to our ingest endpoint in Grafana Cloud. You can also back up write failures to S3 just to hold on to your data in case there's some service disruption. But yeah, so basically this lets you stream metrics to Grafana Cloud instead of configuring Grafana Cloud to go pull metrics from your AWS accounts. So then on the Grafana Cloud side, the main driver is this ingest endpoint. It's basically a proxy into Mimir, but it also does a couple other things that are nice. Like it will um, coordinate with some special metrics that I'll talk about in a little bit to enrich the service metrics that get pushed in with additional metadata that otherwise wouldn't be available. There's also some configuration options that you can have to control what kind of data we generate, or what kind of enrichment takes place. So the special metrics I'm talking about are called info metrics, and there's an exporter that we have called YACE, or yet another CloudWatch exporter. It's open source, and we basically have a facility to create a resource called an AWS resource metadata scrape job. And what that'll do is it'll go query the AWS tagging API for all of your uh, AWS resources of particular types that you've configured, and it'll get the resource tags from them. And it'll generate these things called info metrics, where every metric time series defines a label set that identifies a particular AWS resource. So you'll get one info metric series for each resource that you have in your AWS account that you have configured to scrape. So this collects info metrics. It works on our hosted Alloy cluster, and it'll write those info metrics to Mimir. Now, these info metrics are analogous to like OTel's target info metric standard, but this came before that standard existed as far as I know. So it is kind of like a custom thing for right now, but long term we will try to adopt that standard. Um, but anyways, for right now, these metrics get collected in this format that's like AWS underscore service name underscore info. So if you're collecting like EC2 metrics, then it'll be AWS underscore EC2 underscore info. So the info metrics get written to Mimir, and then our ingest endpoint, when it receives batches of metrics from Firehose, it will automatically go look at the info metrics for that service in Mimir for your, account, and it will enrich those metrics according to your, configuration uh, on the ingest side to enrich those service metrics and ultimately write the service metrics as they're enriched to Mimir. And that helps drive, cool things that we'll go into in the cloud provider observability app. Like we have curated service overviews, we have alerts. We're starting to get heavily involved with integrating with our new knowledge graph product. So there's a lot of opportunities to like get enriched and useful signals from your AWS resources into Grafana Cloud. So now I'd like to show a little bit about how, you can get this set up in your Grafana Cloud account. So I'm in the, cloud provider app in Grafana Cloud, and if I go to the AWS page and go to configuration, there's a metric streaming configuration card. Uh, we're going to focus on the Terraform option today, and I'm not going to go into the full detail of the snippet, like that's covered very well by our documentation here, but I will just say that this brings you to a docs page. We have a stream, we have an example snippet of how to set this up in AWS and Grafana Cloud with like one snippet with some variables that you fill in. I have that downloaded here and pretty much just filled out with like the standard variable values. Like for the most part, I'm using the defaults for everything and just overriding like the required variables. And you can kind of see here, like we have a metric stream, like it got created with a few include filters for these different namespaces, and these are all like access policies, so not super interesting, but and then we have the resources that get created in Grafana Cloud to scrape the info metrics that we talked about earlier. So that all gets defined within like the same metric, the same snippet that's in our docs. And you can kind of see, like I just did a plan here just to show like this is all applied to like the environment that we're applying it to. So if I go back here, so yeah, if I go to Grafana Cloud and go to the overview for AWS, we can see that we are collecting like data for a number of AWS namespaces, and we can go look at that, data. Like I pretty much have a dummy kind of like set up here with a RDS database, a MySQL database, an SQSQ, a couple Lambda functions. These two are the ones that we're going to focus on. And then I also can look at specific views for those Lambda functions by clicking the link. So just to kind of go over what this setup is, we have a couple Lambda functions mainly driving this. One Lambda function is called the SQS generator, and literally all it does is randomly insert messages, one of three kinds, into an SQS queue, and those are weighted. So like, inserts are more likely to get inserted into the queue than the other types, kind of a thing. So this is just like every minute, like randomly pumping messages into the queue. And then we have a consumer here, the SQS to RDS controller, and that's going to read from the queue and do certain database operations according to the messages that get sent. So it's just reading from the database like some dummy table that we've created, or it's going to like insert records into that table, like some random number of records up to a maximum amount we've configured for the table to be able to store, or it might even clear all records from the table, which will happen if either the clear message gets sent on the or gets read from the queue, or if the number of records that would be inserted would exceed the maximum, then we start back over from zero. It's just to generate some random workload on the database just to kind of show off our integration here. So what I'm going to do, like you can kind of see right now that this is running pretty well, right? Like, I mean, it's not like the fastest running Lambda function, but it's like, 11 seconds, whatever. There's some number of errors, or there's no errors currently for this Lambda function, or for any of our Lambda functions, I should say. We also have a log streaming integration, which I've set up here. So like if I go to the AWS page again and go to the logs tab, I have a couple log groups, like one for each of these Lambda functions. And if I look at the one for the controller, then there's no errors or anything. We can kind of see in the logs here that it's inserting records. There's a record limit. It's up to like, about a third of that right now. And it's currently doing stuff. So that's all cool. So everything seems to be running smoothly. CPU on the database is all good, whatever. What I want to do is start creating some failure state in this whole system so that we can start seeing what happens when things break down. So for that, I'm going into the RDS proxy that lets the Lambda functions talk to the RDS database, and I'm going to modify that. And I'm going to change the client authentication type to one that isn't going to work. So I'm going to change the client authentication type to from MySQL native password to this other one that is going to basically make authentication to the database start to fail. So we're going to let that modify, and it'll take a little while for things to start ramping up. So we'll be back after, a few minutes of cook time and see where we're at. All right, so we're back now, and we've been sitting with this change for a while where we changed the client authentication type of the RDS proxy. So now if I go back to our main overview here, I can see that for our Lambda service, we actually do have one of our integration alerts firing. And yeah, it looks like one of our Lambda functions, the SQS to RDS controller, is getting an invocation failures alert. So if I go to the page here, it seems like, oh yeah, we got quite a few errors for our Lambda here. If I go to like our logs page, I can see that, for quite a bit now, we've been ingesting a bunch of error logs, like thousands of error logs for this. So this is failing quite a lot. Basically the Lambda function isn't able to authenticate to the database anymore. So, now at least we know like that change caused that. So we can go back and modify that to revert back to native password and give it a couple more minutes, and we'll see what the behavior is then. All right, we're all back now, and we can see after we've applied the change and waited a little time that everything's back to healthy. The alert condition's gone. Our log streaming also reflects that all the errors since that time range have since stopped. Our dashboards show like our database is healthy. It never really got super high on CPU utilization or anything like that. That's fine. Our SQS view shows that the approximate age of our oldest message is caught back up. So, recent messages are getting processed. Nothing's getting really backed up there anymore. And then our Lambda dashboard shows that there's no more errors recently, and that like our durations are pretty much back to what we were seeing at the beginning. So yeah, that's just a little taste of like using metric streams to send metrics into Grafana Cloud, and then tracing an error through the system and resolving it and seeing what that looks like through our different service views. Hope you found it useful, and I hope you get a lot of value out of our metric streaming integration. Thanks. Have a good one.